Okay, good morning for those in Europe, and good afternoon to those in Asia. Myself, Yuzari from Apex Sales and Support Team, and together with my colleague Antoine from our engineering team, welcome you to our second training webinar of Open eVision Easy Deep Learning. Okay, for those of you who did not attend the first session, no worries. All the 3 parts will be made available on Euresys YouTube channel after the last session. So keep in touch if you want to review the lessons from YouTube or you just want to share it to your colleagues or customers. For the presentation materials itself, we will email it to you a few days after the last session as well. We will try to keep the training within 1 hour. However, if we goes beyond that, we apologize here in advance. Oops. Again, here I encourage you to download our free Easy Deep Learning Studio from our website if you have not done so. Okay. All right. Let us do a recap of what was covered on the previous session before we move on to today's training. On the last session, Antoine describes to you what is deep learning and how he makes a quick comparison between deep learning and traditional machine vision methods. He then moves on to detail the differences between our 3 Easy Deep Learning library, which is EasyClassify, EasySegment, and EasyLocate. We then show you the steps to install our Easy Deep Learning Studio so that you can start to use it to make tests and evaluation. Finally, Antoine shows you the structure of Easy Deep Learning API, and from there you can also see how simple the code is when with the provided snippets using EasyClassify. Okay, we had some questions during the last session. As promised, let us address some of those questions here. The first question is, can I purchase EasyClassify, EasySegment, or EasyLocate license individually? The answer for this is no. We currently offers all the 3 licenses as a single Easy Deep Learning bundle. All right. The next question is, can I use Easy Deep Learning Studio to build my application? The answer for this is again no. You can only use Easy Deep Learning Studio for evaluation. In order for you to build an application, you will need the API to program in C++, okay, or C#. Okay, and for that you need the API. Hence, you need to purchase the license. Okay, for the last 2 questions, can a third-party network be used with Easy Deep Learning? And can Easy Deep Learning handle multiple GPU, and what is the maximum? Okay, for these 2 questions, I let Antoine answer, and after that, he can move on to today's session immediately. But before I hand over the stage to Antoine, if you have any questions, you can type into the webinar Q&A box or email to the address shown on this slide. Okay, we will try to answer them on the next session, or we reply to you directly via email. All right, thank you for now. I let Antoine take the mic. Antoine, please.
Yes, thank you, Yuzari. So I'm gonna share my screen. So I'm gonna go back to the 2 questions I really did not answer. So can a third-party network be used with Easy Deep Learning? Well, it's again a no at the moment. You can only use the neural network that we have designed and optimized for industrial application in Easy Deep Learning. And the other question was, can Easy Deep Learning handle multiple GPU, and what is the maximum? Well, yes, it can handle multiple GPU. The maximum is the maximum number you can put in a computer, in a workstation. So usually it will be 2. And on the very high end, you may be able to buy a 4 GPU workstation. And Easy Deep Learning can support that. But we will see in the next session, next Tuesday, how exactly are the limits and how to use these multiple GPUs. So let's go to session 2, which is how to get the most out of your data. So today we'll be talking about your images, about your data, about how to specify your problem and the labels, the characteristics that you want to detect, to analyze in your images. So we will start with some criteria to match a deep learning tool to your problem or your images. Then we'll talk a bit about the number of images that you need to train a deep learning model. Then we will talk about the size of those images. And then we'll go to the most important section of today's session, which is how to correctly and properly annotate your images. This is one of the most important steps of all deep learning applications, so it's really important to annotate your image correctly. Then we'll go on to how to split the dataset into multiple parts and understand why it is very important to split your dataset into multiple parts. And finally, we will see the various data augmentation settings and how to configure and use them with Deep Learning Studio. So let's start with choosing the best library for your data. So here, I would like to talk about 3 criteria that you can base your decision according to what you see in your data, to what you want to detect in your data, to choose the appropriate library. So the first criteria I will talk about is the number of elements that you want to detect and identify in your images. Another criteria will be some kind of trade-off between the time that you want to invest into the annotation of your images and the precision of the results that you want to get. A third criteria is the size of your image and the size of the pattern of the defect that you want to detect in those images. So let's have a look at the first criteria, the number of elements that you want to detect in an image. So I've made a small flow chart here that shows, according to yes or no question, which library is best suited for this purpose. So basically, if you want to detect more than a single element in an image, then you need to use EasyLocate and or EasySegment. Which library depends on exactly on what you want to do. If you're really interested into a pixel level precision of your defect of your product, etc., then use EasySegment. Otherwise, if you are more interested in counting the number of element of object that you have in your image and that your object can overlap or touch each other, then EasyLocate would be most suited for this kind of application. Then when you have a single element, a single characteristic that you want to identify in your image, then if you need a precise localization, you still can use EasyLocate or EasySegment. But EasyClassify is also a very good library for such a case. It will give an approximate localization, and it is the library that will give the best speed performance. So the second criteria that I would like to talk about is the trade-off between the annotation time and the precision of the result. So I have put all the libraries in the 2 mode of EasySegment on a graph. And as you can see, the more time you take to annotate your images, the more precise the result you will have. And so EasySegment unsupervised will be the simplest library to annotate for, but it may also be the library which will give the worst result on average. Then we have EasyClassify, then EasyLocate, then EasySegment supervised. The third criteria was about image size and the size of the pattern or elements that you want to detect in this image. And so it is especially the case when you have a very big image, like HD image, with a very small pattern that you want to detect. Then EasySegment would be the most appropriate choice because EasySegment can work with any image size and will always work at the native resolution of the image that you give it. On the other end, EasyClassify and EasyLocate are both limited to around 1 megapixels images. And so either your pattern is big enough such that if you resize your image to a 1 megapixel image, the pattern is still there. Otherwise, you will have to do extra work because we need to cut your images into smaller images and annotate all these smaller images and measure the result afterwards yourselves. So if you have no idea which tool to use and the 3 criteria that I just talked about didn't help you, then my advice would be to test them one after the other according to the annotation time, to the time you will have to invest into the annotation. So first try EasySegment supervised, then EasyClassify, then EasyLocate, then EasySegment supervised. Okay, we'll go on to the second point of this session, the number of images that you need to train a tool. Well, this is a very hard question because there are a lot of problems that we can solve with deep learning algorithm. And the correct answer to this question is it depends really on the complexity of your images and of the pattern that you want to detect in your images. So a general rule of thumb is that you have to provide enough examples to the deep learning algorithm for the model to learn general features about your data. It can work with as few as 10 images, but for many problems, it will also require more than 100 or 1,000 images. Also, I would like to mention that we have various features or functionalities, such as data augmentation and pre-trained classifiers, that can help you decrease the number of images that you need to obtain a good model. Also, simply giving a number of images is not really the complete answer to this question, because most datasets are unbalanced. What does that mean? So, for example, if you are in a defect detection application, you have images of your product in its good state and images of your product with defect. Usually, because defects are much more rarer than the good images, you will have a dataset, for example, of 1,000 good images and 50 bad images. This is called unbalanced. This is because the 2 labels do not have the same number of images. And in Deep Learning Studio, we can have that, and usually it will work well until you have one of the 2 labels that do not have enough images. So basically, the minimum number of images I talked about on the previous slide, so the minimum of 10 images, it's more 10 images per label that you want to identify. So a dataset with 1,000 good images and 2 bad images will not work in practice. So this is why in Deep Learning Studio, in the label list, we have displayed the image count, the pixel count, and the object count for EasyClassify, EasySegment, or EasyLocate, because it is at this column that you have to look to see if you have enough images that for training your tool and recognizing and learning correctly about all your labels. So now let's talk a bit about working at the best image size. So the main point I want to make here is first that in deep learning application, the image size is the main determining factor of the processing speed. So you always try to have the smallest image possible in your dataset and on your production line. And it is that will make the neural network go faster. So now let's see a bit about, for each library, what image size you must use, what are the limitations. So for EasyClassify and EasyLocate, they need images with the same size as the input of the neural network. So the size can be configured for each of the tools, and the images in your dataset can have a different size. And the images in your dataset do not need to have all the same size. They will be automatically resized to the size you specify for the tool. Also, if your images in your dataset have a size bigger than the maximum supported size, then by default, your images will be reduced to the maximum size of the tool. But you need to take care of the fact that your defect or your product might disappear from your image when they are scaled down. So if your images cannot be scaled down, you will need to divide your big image into smaller sub-images. And this is the purpose of this slide. So if you have big object of interest into a big image, then you can simply use the automatic resizing of EasyClassify and EasyLocate. So your big image will be automatically resized for training. However, if you want to identify a small object of interest, then you will need to divide your big image into smaller image, and then you will need to add the smaller image into Deep Learning Studio, because you need to annotate each of the smaller image individually. Because here we had, for example, one big defective image, but after division, we have 8 good and only 1 not good. So it's really important to perform the annotation on the smaller image for EasyClassify and EasyLocate. Also, within Deep Learning Studio, you can export your dataset to resize all your images in one go. So when you click on export, you will get this dialog where you can resize all your images. And then you can create a new project, import the resized dataset, and then you can train faster with your smaller images. Then there is EasySegment, which can use any image size as input. This is because this is the library that will automatically perform the subdivision of your input into sub-image. And there is 3 parameters for EasySegment that will control how the image will be used and subdivided. So there is the scale, the patch size, and the sampling density. The scales allow you to quickly test a model at a low resolution. The patch size is the size of your sub-images. And the sampling density is how much overlapping you will have between all the sub-images. I encourage you to go look at the documentation for the 3 parameters. I do not have the time to go deeper into how they are defined. But my advice here would be to always try the default values of these parameters first. So we can also look at this flowchart, which shows how your image is transformed for EasySegment. So you have your original image, then the scaling parameters will be used to perform downscaling. Then the patch size and the sampling density parameters will be used to extract patches, sub-images from the scaled down image. Then we apply the neural network on all these patches. We merge the results, and we scale back to give you an output the same size of your image. So this is how it is performed internally by EasySegment. So now what about the image size at inference time on your production line? So we'll go back to EasyClassify and EasyLocate. So for example, if you perform your training with 1000 by 1000 images, but you have configured your EasyClassify tool, for example, to be 256 by 256 pixels. So during training, as I said, there will be an automatic resize of your big images. At inference time, you can do the same. Use the same size of image as your dataset, and let EasyClassify or EasyLocate perform the automatic resize. Of course, this resizing operation will require some additional processing time. So there is two other solutions. One would be to use the OpenVision API to perform the resizing of the image yourself in another thread. This will improve the performance of your application. And maybe the best solution would be to make your camera or frame grabber do the resizing, if it is an option for your frame grabber camera. And in that way, you will get faster automatic resizing because it will not be the CPU or the GPU that will do it. And the GPU can concentrate on running the neural network. For EasySegment, the flowchart is the same at inference time. So we'll use the same image size as the one you have in your dataset. Okay, now let's go to the biggest section of today's session, which is about annotating your images. So as I said in the introduction, the annotation of your image is the most important step in deep learning. Because if you have bad annotation or badly defined labels, your result might be and often will be unstable, and the training may not work at all. So you may train for 1000 iterations and you will not see anything in your results. Also, by annotation, it is what is called the ground truth. So the ground truth is what you want to predict for the image, is the expected result for the image. So this is also what you want the model to learn inside your image. So what is a bad annotation exactly? Here I have three main criteria. Inconsistent. So if you have labeled one image is one way and another similar image is labeled another way, this is inconsistent. And usually deep learning application will have a hard time with inconsistent labels. So this is here the examples. We have two waffles, which are quite similar. They are both have a broken part, but they are labeled differently. Also, when multiple labels can match the same image. So for example, if you have several defect labels, and these two defects can happen at the same time in the image. And this is a bad annotation for EasyClassify, for example. For EasySegment and EasyLocate, a bad precision in the annotation is really a bad annotation because it will make training harder because it will need to eliminate the bad part, the bad precision of the annotation. So the consistency, is really, really important. And especially when you have a big data set and the annotations are performed by more than one person. Because usually when several persons will annotate the same dataset, they will make different decisions for similar images. And so if you want to make more than one person annotate a dataset, then you should really have clear, consistent, and repeatable procedures for labeling your images. You may even need to train the people who will annotate the dataset before they start annotating to make sure that all the annotation will be consistent. Also, deep learning training and algorithm can deal with a small amount of badly annotated image or inconsistencies, but less than 1% usually. So for small datasets, it's really important that you do not make mistakes in your annotation. Otherwise, the result might be very poor. Also, one advice to check for the quality of your annotation is to analyze your results. If your annotation are not too bad, then the model will learn at least partly how to recognize your images. But by analyzing where the model has made mistakes, so here we look at the single images that we annotate as good, but is predicted as bad by the model. And so we might want to reconsider the annotation for this image. Because here, for example, we see that there is some kind of broken part on the waffle here. We also see the probabilities which are not clear-cut. So the model hesitates between the two labels, good and bad. And so here, we might want to change the label and say it is a bad waffle. If we do that, we need to retrain another tool to make sure that it is trained with the correct label. Also, especially if you deal with natural products, you will always have some unclear cases. So waffle where you don't really know if it's not good or good, there is no clear split between the two. So you can handle this in two ways. First, you may use another tool. For example, for this image, we could use EasySegment supervised or EasyLocate to find the size of the broken part of the waffle and do post-processing on the results to analyze if the size is bigger than a threshold, for example, and make your final decision about the nature of the defect according to that. The other way to deal with unclear cases is to simply accept that your deep learning model will make some errors, and then sometimes you will accept a defective product or you will reject a good waffle, for example. So, as I said, it's very important to have correct and good annotations. This is why in Deep Learning Studio, you can have partially annotated dataset. So by default, when you add images into Deep Learning Studio, they won't have any annotation. So you cannot train with the image that you have just added into Deep Learning Studio because you did not say for each image what was its ground truth. So here on top of the label list, in Deep Learning Studio, we have displayed various statistics that shows how many images are without annotation, which are called unlabeled or no segmentation, and how many images are labeled or with annotation, or also called with segmentation for EasySegment. So the unlabeled images, or images with no ground truth, no segmentation, they won't be used to train a tool. Since we do not know the ground truth for this tool, they can't be used to train. They will be placed in the test set. We'll talk about the test set later on in this session when we talk about dataset splitting. But still, a result will be computed for these images. So we see here in the confusion matrix that we have one unlabeled image. However, all the metrics, so the accuracy, the precision that you see on top of the confusion matrix, are not computed with the unlabeled images. Because in order to obtain the accuracy, we must compare the result with the ground truth. Since we do not have a ground truth, we cannot compute the metrics with the unlabeled images. Also, and we will talk about that later on and in the next session, you can decide to use a result for an unlabeled image as the ground truth. So you can import a result as the ground truth annotation of your image. So this is really a useful tool that allows you to quickly increase the number of labeled images in your dataset. So the labeled image will be used to train and validate the model during training. They will be also used to test the model after training. And all the metrics, accuracy, F-score, etc., will be computed only on these labeled images. So let's go to the labels. It's also a very important step in the annotation of your images, is to choose the correct set of labels that you want to recognize in your images. In OpenVision Deep Learning Studio, a label is defined by its name, a color, and a weight. Be careful that the name cannot be changed once the tool is trained. The color is mainly used for display purposes, and the weight can be used to put more weight on particular labels during training. So for EasyClassify, a label must be a unique and independent characteristic of an image. So in the example here on the right, we cannot have for this image two different labels. So for example, whole and broken, because there is a hole in the middle of the waffle and a broken part here. So here we have two choices. We either simplify the labels, and for example, here we have merged the whole and broken into the not good label, or we use another library, as we have told at the beginning of this session. When you want to detect multiple things, then you need to use EasyLocate or EasySegment. Here I have chosen EasyLocate. So how do we annotate for EasyClassify? Well, it's one of the simplest library to annotate for. So you simply select the label on top of the image thumbnail in the image list of Deep Learning Studio. You can also type directly the label that you want. If the label did not exist before, it will be added automatically to the label list. And you can also perform selection and perform right-click to set a label to a selection of image. The final way to annotate the ground truth for EasyClassify is to open the image into the image viewer. Then we have the ground truth tab, and we can select also the correct label for the image here. So we talked now about the annotation for EasySegment and supervised because they are very, very similar to the annotation for EasyClassify. So EasySegment and supervised only need to train with good images. So we only need to indicate which images are good and which are bad. So in practice, we only need one label for EasySegment and supervised, which is a good label. You can create as many labels as you want still, but there will be only one label that is good, and all the other labels would be bad labels. And so you can specify which of the labels that you have defined is a good one. It is not mandatory that it is the first one that is the good label. Then you simply annotate your images in the same way as EasyClassify. Now let's talk about the annotation for EasySegment supervised. So if we look at the with segmentation, so the images that were annotated, we saw that there is two subcategories here. The background no foreground blobs and the with foreground blobs defective. These two categories are mainly used for defect detection application. So the first one would be images without any defects, and the second category would be images with defect. So in the segmentation labels below, we have the first label, which is named background, and it has a special status. It cannot be removed. You cannot change its name. And basically, it's the default label for most of the pixels in your image. So because usually most of the pixel will have no useful information for your application, you simply let all those pixels to be to the background label. And then you will need to add labels to identify the useful information in your image. And so basically, the first category here for good images are images where all the pixels are background pixels. The second category is images that contain at least one pixel that is not background. So in this case, it would be a defective pixel. So for EasySegment, supervise the precision of the annotation is relatively important. It will influence the results. However, that doesn't mean that you need to be pixel perfect and draw extremely precisely. The main thing to do is to be consistent in your annotation and in the precision of your annotation. Here I've shown several examples of good and bad annotation. So here it is a bit too small because we see that we could be closer to the edges of the defects. Here it is quite good, and here it is too large. This case is worse than this case because here at least we follow the edges of the defect and we are close to it, while here we do not follow the edge of the defect at all, and it will be really bad for training. Again, it's best to have a few well-annotated images than a lot of badly annotated ones. So take your time when annotating for EasySegment supervised and try to annotate well a few images, then train, and then you can iterate on your dataset after that. Also, for EasySegment supervised, the labels that you want to detect, they must characterize the appearance or the pattern of the pixels. So in this case, we see that we have 1, 2, 3 defects. We cannot assign different labels to these only because they have different size. Here, all the 3 have the same appearance, so they must have the same label. If you want to do some kind of post-processing based on the size, then you do that during post-processing. So you get your results, and then you look, for example, at the area of the blobs detected in the image, and you can threshold this area to detect the actual defects for your application. So when you annotate images for EasySegment supervised, we have provided a lot of drawing tools. I will not go over each of the tools. I will show a small video on how to annotate properly. I invite you to look at this slide later on, or pause if you look at the YouTube video to see all the available tools. Also, we have a lot of keyboard shortcuts when you have to annotate a lot of image, it can be much quicker to use the shortcuts. So they are displayed when you hover a mouse on top of one tool. You will see what the tool do and the shortcut associated with it. And mainly when annotating for EasySegment supervised, you will use the polygon shape and the freeform drawing tool. So let's have a look at an annotation. So here I zoom and unzoom the image to see the image into its entirety. I identify where are the defects. And here I click on segmentation to say, okay, now this image has a ground truth segmentation. For now, it's completely background. So I selected the defect level, and then I select a tool to draw on top of the image. Here I just show some of the tools and some of the manipulation for the rectangle ellipsis tool. So we have also undo and redo button. So if you have made a wrong manipulation, you can always go back to a previous state. And now we'll annotate. So I zoom quite a bit around the defect, and I have used the polygon tool. And with the polygon tool, I simply put points around my defect. The final point, I use a double click to say that the polygon is now complete. Once the polygon is complete, you can still add or move some of the points. And of course, you can still undo and redo what you have done. So if you go back to the selection tool and re-click on the polygon, you will lose all the points of the polygon and will become a blob. When it is a blob, you can only move the blob, but you cannot edit all its points. Here, I will show the freeform drawing tool. So you click on the tool and you select the width of the pen you want to draw with. So as you can see under the mouse, there is a circle that shows the size, the width of the pen that you will draw. So here, I will draw the contours of the defect and then fill the inside of the defect. And so this is two ways that you will mainly use when annotating for EasySegment supervised. It is the polygon and freeform drawing tool. We have also grow and shrink operation. You can right click on the blobs and change the labels of the blobs. And when you have finished annotating a given image, you need to click on apply to save the result for this image. So now let's go to the annotations for EasyLocate. So EasyLocate finds objects in images, and basically an object is an abstract term which represents a bounding box and a label that indicates what is contained within the boundary of this bounding box. So compared to EasySegment supervised, we see that there is no background label, but there is still two subcategories here that have the same role as EasySegment supervised. So we have the no object category, which means that we have a ground truth for two images here. And this ground truth here is we do not want to detect anything in these two images. And then we have the big part of the dataset that contain images with at least one object. And so the labels here that we define are only labels for objects that we want to detect. So again, the precision of the annotation will influence the results for EasyClassify. it is always best to make the bounding box close to the corners or the borders of the objects that you want to locate in your images. And it's really important, again, to be consistent in the precision of the annotation. So if we look at the image viewer of Deep Learning Studio, there is two annotation mode for EasyLocate. The first mode is the add object. So you will see your mouse cursor change. It means that if you click and drag your mouse, it will create a new object. Then there is the edit object mode. In this mode, when you put your mouse over objects, you will see the handles that allow you to resize or change the label of the object. Also, the edit object, you can hold the control key and it will quickly go to the add object mode. And so my advice would be to remain in the edit object mode and hold control each time you want to add a new object. And this is what I will show here. So I have an image and I'm in the edit object mode. And you see at the bottom when I hold control, so I select a label, I will hold control and I drag my mouse to select the tool. Usually for EasyLocate, I will perform a first pass where I will annotate each of the object that I want to detect very quickly and do not care very much about the precision. And then in the second time, I will go over each of the annotation I have made and adjust the bounding box a little bit to make it closer to the edge or corners of all the objects. Okay, so here we are going to talk about using a train tool to increase the number of images that are annotated in your dataset. So basically, when you start a new deep learning application, you will add your images to Deep Learning Studio, and you will have a set of unlabeled images. So all your images have no ground truths. You cannot do anything with them. So the first step that you will have to take is to manually label some of these images. So you will say whether they are good, not good, or you will draw the segmentation, etc., etc. And then you will get a smaller set of labeled images. With these images, you can try to train a tool. So you will go to the fourth tab of Deep Learning Studio, create a new tool, and train with it. At the end of the training, the tool will be applied on all the images in the dataset. The labeled images, but also the unlabeled images. And so you can look at all the predicted images, especially on the unlabeled images, check whether the predictions are good or not. And for some of the images where the prediction is good, you can simply accept the prediction at the ground truth, even possibly adjust a little bit the ground truth of the image if it was not precise enough, if the prediction was not precise enough. And then you also need to manually annotate some of the images where the prediction was really bad to increase new information about your images, such as the training can perform better on the next iteration. And so this is really one way to quickly develop a deep learning application. So you annotate a few images, you train, and you use the prediction to increase the number of annotated images and see which image you need to manually annotate. So in Deep Learning Studio, we have several ways of using a result as a ground truth. So you can use this button, which will accept the entire prediction as a ground truth. My recommendation is, when you do that, is to quickly go to the segmentation here, for example, tab, and fix the precision of the annotation. And you can also accept individual blobs or objects for EasyLocate into the ground truth by right-clicking on them. So also, all the annotation are possible to do with the C++ and C# API. Please look at our user guide and reference the documentation to see how you can do that. It will be mainly using the eClassification dataset class that you can do your dataset and set the annotation for all your images. And it can be useful to manipulate this class to import or convert dataset created with our tool, for example. So now let's go and we'll talk about splitting the dataset. So it's an important step to split your dataset. And why is that? It's because in order to know if your deep learning model will work on your production line, we want to get some statistics, some metrics, some kind of number that evaluate the performance of your tool. And statistically, to obtain valid values that you can trust, then you need to compute these metrics on images that were unseen during training. And so this is why ideally we need 3 sets when using a deep learning application. We need the training set, the validation set, and the test set. So I have a description of each set here, but I have a flow chart on the next slide, which better show how each of these sets are used. So we see that the training set and the validation set are both used during training, and the test set will never be used during training. So in the test set, we will have images that are unseen by the training algorithm. And it is by using this test set that we can compute the final metrics, so the metrics obtained on the final trained model. And that is these performance values that statistically are the best approximation of the performance of your application. So, and during training, the training set is used to update the model directly. So the deep learning model is directly trained on the training images, and the validation images are used in the training algorithm to get the best model on a part of the dataset which is also partially unseen. So basically, for each iteration, we train with all the images from the training set. At the end of the iteration, we compute some metrics on the validation set. If these metrics are better, then we keep the model. Otherwise, we continue the training to the next iteration and try to get a better model. And so the validation set is mainly used to avoid what is called overfitting. Overfitting is when we learn to recognize the specific images of the training set and not the underlying features that we want to detect in the image. So on the left, we have a small toy example where the colored dots would represent images with different labels. And the yellow line would represent an overfitted model. So the yellow line is a perfect classifier. It separates the blue and orange dot perfectly, but it is an overfitted model. A best model would be the green line, which separates, which is simpler and separate also more or less correctly the blue and orange dots. Why does the yellow line is called overfitted? Why mainly is because, for example, this blue dot, which is correctly classified with the yellow line, was in fact a mislabeling. Yeah. And so this is the best model. If we look on the right of the screen, this is the typical graph that we will see when we train a tool. So here we have the the number of training iteration on the x-axis, and some kind of metric on the y-axis. The lower, the better. And so the metrics on the training image will usually always decrease, but the metrics on the validation image will decrease at first, and then there is a time where it will no longer decrease, and it might even increase. At that point, we have the optimal model that will give the best result on new image on average. If we keep the model of the last training iteration, then we will have worse result on the validation image. And this is called an overfitted model. So basically, the risk when using 100% of your images in the training set is that the model will perform badly and simply recognize the specific images in your training set and on the underlying features. As for the role of the test set is really to get the best estimation possible of the performance of your tool in production. Also, I would like to advise you to train several tools with different dataset splits to get an even better estimation performance of the tool and to see which split perform the best with your data. So how many images do you need in each of the sets? Well, in general, you need more training images than validation images and more validation images than test images. The default values in Deep Learning Studio are a proportion of images of your dataset. So it's 70%, 20%, and 10%. But it also depends on the total number of images in your dataset. Because validation images and test images are both used to compute metrics, to compute performance values. And these performance values, to be valid statistically, need to be computed on at least 10 or 20 images. So if the validation or test set are too small, so less than 10 images per label, then the metrics that are computed on these images will not be statistically relevant because there is not enough images to do a correct averaging. And so for smaller data set, it is better to do without the test set. And for a very, very small data set, you can also do without the validation set. Of course, you really need to be careful with the result when you train without the test set or validation set, because the metrics, the performance indicator that you see in Deep Learning Studio might be false. And so my recommendation would be at least 10 images per label in each of the sets. So now let's see how to create splits. So the dataset split are defined in the second tab of Deep Learning Studio. You simply click on the new button and you can specify a name and the number of image or proportion. The splits are drawn randomly, but you can still manually edit the split of each image individually afterwards. Also, we have a small lock next to each split. And so a split becomes locked when it is used to train a tool. Before that, it will be unlocked. When the split is locked, it means that the training and validation images must remain in the set. So they will be also locked to their training or validation set. In a locked split, only the test images can be moved manually to the training or validation set. Also, one interesting information is that if you add new images after you have already created a split, then these new images will go to the test set. So to manually control the split of an image, so you select the split for which you want to manually edit some of the image. And then you can either right-click on an image and select the correct split, or click on the dataset type here to change it. So when do we recommend to manually select the split for your dataset? Well, if you have, for example, a very small number of images and you know in advance that some of the image are more representative of the problem that you are trying to solve, then you can try to put these images explicitly into the training set to make sure that they are correctly learned. Also, if you want to continue a training, for example, so you have already trained a tool, but now you want to add some new images to the dataset and continue the training to try to improve more quickly, just train for a few iterations. Then you can add the image. They will be put in the test set of your split, and you can move some of the test images to the training and validation set, and then continue your training. Okay, now let's go to the final section for today, which is about data augmentation. So what exactly is data augmentation? They are random transformations that will be applied to your images before we use them in the training algorithm. So in practice, it will artificially increase the size of your dataset by generating new transform version of your images. What it does usually is that you will get better results, or it will make your model more robust with respect to some symmetries or variation. So for example, if you want to make your model robust to rotations, then you can apply some rotation in the data augmentation. If you want your model to be robust to change in luminosity, you can apply some contrast or brightness data augmentation, for example. So it depends on what you want to get, which data augmentation to use. So when do you need data augmentation? Well, it is not really the correct question, because the answer to that is always. The better question to ask is, which data augmentation do I need for my data? So before knowing which data augmentation do you need to know what are the possibilities. So let's have a look at Deep Learning Studio. So in Deep Learning Studio, you can add various data augmentation settings. By default, there is also the NTL data augmentation that do not apply any data augmentation. And one data augmentation settings will contain the lower and upper bounds for the parameters of each transformation. So for example, if we see this window here, it means that during training, the image might be rotated between minus 90 degrees and plus 90 degrees. They will be scaled or zoomed by a factor which is between 0.8 and 1.1. And they will be flipped vertically or horizontally, or not at all. And this is random. So as you can see, we have three categories of data augmentation, which are geometry, color and luminosity, and noise. So let's have a look at each of the data augmentation. So if you open an image in the image viewer in the data augmentation tab, you can display the lower limits, the upper limits of the augmentation that you have specified here, or see a random augmentation within the limits that you have specified. So here we look at rotation. Here we look at shifts. Then we have the scale. The shear. Flip. We go to color luminosity, whether it's the brightness, contrast, gamma value. And for color images, we also have the hue offset and the saturation gain that can be useful to shift the color space of your images. That augmentation, we have a simple additive white noise, so Gaussian noise. We have also multiplicative noise, also called speckle noise. And we have salt and pepper noise, where we flip randomly some pixels to white or black. So let's go back to the question, which data augmentation to use. Well, in my experience, vertical and horizontal flip will be more frequently used. They are practically good for all datasets. Then brightness offset is usually very good also. A bit of scaling, rotation, contrast, and hue. These are the main 6 data augmentation settings that I use when training. Also, one thing to be careful about is do not apply data augmentation that might change the label of an image. So for example, is the waffle dataset. If we have bad images which are overcooked, then do not use the hue data augmentation that might change this image to this, which would look like bad images. Same here, where, for example, a flip would change the label of the product. Also, with EasyLocate, you must not use rotation or shear data augmentation. This is because for these 2 data augmentation, the ground truth bounding box can be computed after the image will be rotated or sheared. We will lose in precision, and this the training will perform badly. Okay, that's it for today's session. So the main takeaways for today is that it's really important to have well annotated images, and it's better to have few images that are correctly annotated than a lot of images that are annotated badly. You really need to choose the labels that you want to detect in your image with care, because they will influence greatly your final results. You need to iterate between training and using the result to increase or improve your annotations. A smaller image size always means faster training and processing. Be careful with very small data sets, because the performance metrics that we display in Studio might not always be valid, because we do not have enough images to get a good average value. And always use data augmentation, but be careful when you select which one to apply on your data. Thank you very much for listening to me today, and I will leave the mic to use.
Okay, thank you, Antoine. That was very interesting. I learned several new things today, and I hope it has been helpful for the rest of you too. As usual, if you have any question or feedback from today or previous session, our line is always open through our sales and supports email. Feel free to write to us, and we will try to answer it on the next session, or we reply to you directly. All right. We will have our final session next week on September 6th, same time. This session covers the most advanced topics. We will show you, we will show you how to configure and train our Easy Deep Learning tools. We show you how to interpret the result from those tools. We will also provide you tips on selecting the right hardware to use with our Easy Deep Learning. Okay, that's all for today. I hope to see you next week. So bye-bye for now.